Good evening. Good evening to all. Am I audible? Wajid sir, am I audible?
Yes, you are audible, ma'am.
Okay. So, sir, Subhabrato sir and Praveen sir, I am starting. Yes. Good evening, ladies and gentlemen. It's my pleasure to welcome you all to today's Industry Expert Talk. My name is Shravani Pal, Assistant Professor of Electrical Engineering Department, and I will be your host for this event. We are thrilled to have with us today our distinguished guest speakers, Mr. Shubhabrato Ghosh, President Operation in Batrix, the Future Technology, and Mr. Praveen Wakere, Deputy Manager System Integration in Batrix, the Future Technology, who are two experts in today's topic, energy storage future ahead. As we all know, that to reach net zero carbon emission by 2070, the transportation sector needs a paradigm shift by adopting electric vehicles. The success of electric vehicle strongly depends on energy storage device and its uses. Presently, battery being widely used as energy storage device in electric vehicle, whose continuous research and development is going on. So during this talk, our eminent speakers will share their knowledge and experience with us and offer valuable insights into this area. They will also answer any question you may have towards the end of the session. Before we begin, I would like to remind everyone to turn off audio button of your phones to avoid any disruption. Without further delay, please allow me in welcoming our esteemed guest speakers, Mr. Praveen Wakere and Mr. Shubhabrato Ghosh. It's my pleasure to introduce the eminent speaker of today's event, Mr. Praveen Wakere. He has done his MTech in communication and currently employed by Batrix as Deputy Manager System Integration. He specialized in battery management systems, MCU, dashboard, swapping stations, IoT, and software integration. With years of experience and a deep understanding of these complex technologies, expertise in designing and implementing cutting-edge battery management systems, integrating software system with IoT, MCU, and dashboard technology, and developing advanced swapping stations have made him a valuable asset to his team. He is exceptional in problem solving skills and attention to detail have led to the successful implementation of numerous projects. His dedication to staying current with the latest industry trends and technologies has allowed him to create innovative solutions that optimize performance, improve efficiency, and enhance the overall user experience. Now, I also very much glad to introduce another eminent speaker, our today's event, Mr. Subroto Ghosh. He is the President Operation in Batrix, the Future Technology. He is 17 years of expertise as business head, vice president, plant head, president operation, and greenfield projects. He is also expertise in P&L, profitability, business strategy and plan, plant operation, lean OEE, TPM, and R&D section. He was a guest speaker at ASEAN Battery Metal Conference, Shanghai, China, in 2019, and he was panelist at S&P Global and second annual Electric Vehicle Conference, Singapore in 2019. He was business guest speaker at Global Business Networking Forum (JIAT) Korea on December 2018. He was a guest speaker and panelist at EV Charging and Battery Technology Delhi 2019. Panelist in Gujarat EV policy in July 21 and Maharashtra government electric vehicle policy on August 2021. He was a panelist at EV India Summit Delhi 2020 and guest speaker and panelist at EV Innovation Summit at Mumbai on March 2022. and panelist in EV State Summit Maharashtra at Pune on May 2022. He was awarded under 40 top 40 top of 40 top 40 employability leaders by eMobility Plus. Sir, welcoming you in this event, Mr. Praveen Wakare and Mr. Subrata Ghosh. Thank you, sir. You can start your talk.
Yeah, good afternoon, everyone. Thanks, Abhijit sir. Thanks, Swapni ma'am. Thanks, Dr. Arup, for the wonderful introduction. And it's a privilege to for us to talk to the entire the student community and the related community. So I'll just request Praveen to spare 2-3 lines on the introduction. Then I'll start the presentation. Over to you, Praveen.
Thank you, sir. Hello, guys. Basically, we are in the era where electric mobility is going to emerge. It is going to be boom, and for that reason, the backbone, the heart of electric mobility, which is a battery pack, the energy storage device that we have to see in the next 60 minutes, 60 to 70 minutes. So shall I start from?
Yeah, so I'll start with the presentation. Before that, so I'm already connected with Siliguri and SIT, being my hometown, and it's a privilege to talk to the team and the juniors, guide them. So I always guide my juniors as well to to go in the right path. We can remember, like, we can remind about the time when we had no guidance in the year maybe 2006-7. So it's a very it's a era of communication. It's an era of data, and I think so. That's the best part. So everything is available, and how to use that data, and that's more important. So starting with the EV industry, as rightly said by Praveen. So I'll tell you the story. So after that, we'll start the presentation. So definitely, so 4 or 5 years back. So I'll just open the presentation and try to explain the presentation. Yeah, so we are from Carbon Extrusion Technique Limited. It's a 40 years old listed company in Bombay Stock Exchange, and it's the part of Colside 1500 group, Colside Group, and so we started the journey of EV just 2-3 years back. So even I can share you about the Indian journey on the EV. It started in a very non-standard way. People started getting. So I'm talking about 2014-15 onwards. People started getting the EV kits from China, and like your sheet metal parts, plastic parts, electronics parts, unique components of your EVs, battery, chargers, everything in SKD and CKD part from China, and then assembling it in India, then selling it in various part of India. So that's how the process started in India, and nobody practically had any knowledge about the electronics, the lithium battery, the electric vehicles, controller, the cluster, how the protocol works, what is right, what is wrong, how to use, what is 48 volt, what is 60 volt, 72 volt systems. We have seen people who are abusing EVs like anything. So this is how it started. But to be very frank, on a positive note, in last almost 7 years, I've seen a lot of changes in Indian EV industry. Especially, this is how it starts in any of the the country. And then we had different challenges like high lithium battery cost, no history of lithium battery performance and impact. So practically no data were available, no such design and studio except auto giants. So like if you talks about the auto giants like Mahindra, Tata, or Hyundai, Honda. So apart from those, you hardly had any design studios. No Indian design product, charging time. So basically, everything was copied from some other country and using it as per Indian infrastructure. The charging time is high. No infrastructure for fast charging, swapping, lack of EP supply chain, high capex because your EV costs are higher than your ICE vehicles, being a two-wheeler, three-wheeler, four-wheeler. With a high cost of tooling, even the volumes were low, so no, the suppliers were not ready to supply to the new age OEMs. So plant setup, design changes. So there are a lot of challenges for EV industry. But somehow it started into the 6-7 years back. To be very frank, uh, till before 2021, I think June FAME 2 subsidy came into the place. So 2011 National Council of Electric Mobility. So this is the kind of I hope it is visible. 2011 National Council for Electric Mobility setup. So this is the kind of the different
Sir,
milestone.
sorry to interrupt you. If you can put it in full screen mode, it will be, I think, better visible to others.
Okay, I have put it in full screen, but it is
Not.
not showing in full screen, right?
Yes, it's not showing.
Okay, just let me try. Is it better now?
Mm.
Now it's full screen, right?
Yeah. Yeah.
Yeah,
Okay.
it's okay now.
So I think that's very important how the government supported in the EV policy, and that is one of the reason why in the countries like China, Singapore, US, Amsterdam, uh, the EV growth people have seen because of the support from the government because of the high capex. So it is very important that the government support in EV infrastructure. October 2012, National Automotive Board (NAB) constituted. Then April 2015, FAME 1 started. As you know that the FAME subsidy started to support the MSME and EV manufacturer to sell their scooters because in the years 2015 16, the cost of EV were almost 30 to 35 30 to 40% higher than ICE because of the high cost of battery as well as the import charges and the tooling, the high cost of local parts. So because of that, it was always required to for a subsidy. So this is how started FAME 1, which was not very effective in my opinion. And then FAME 2 started in the year 2019 March. FAME with the FAME 2 subsidy, the growth we can see the enormous growth in the EV subsidy, especially after 2021 uh, when the government of India extended the FAME 2 subsidy, and we can see the enormous growth in EV EV manufacturer. And this is the time when 2021 when the customers started adopting it. It was very important because customer were not adopting the EV before 2021. I can say after 2021 with a good amount of subsidy by the central government as well as the state government. So from last 2 years, almost the kind of subsidy what we so there are different subsidy scale in different states. Although on an average, you can see if you are a thumb rule, if you are purchasing a two-wheeler, if I talk about the two-wheeler, uh, if you are purchasing a two-wheeler on around 90,000 or 1 lakh, so you get a subsidy of around 30 to 35,000. So basically, your 30 to 35% subsidy you get out of the total two-wheeler EV, which is almost equivalent to the battery cost. So basically, with the addition of state as well as the central government subsidy. So basically, your battery comes free. So and this makes it competitive with the ICE. And your operating cost is almost one fifth compared to an ICE, your EV running cost, including your running as well as maintenance cost, because your the battery and the motors and the controller have less part compared to engine. If you look at two-wheeler, three-wheeler, or four-wheeler, or buses, or commercial trucks, trailer, the major part of your 80 to 90% maintenance or service are related to the engine. So because engine have more rotating parts and moving parts compared to your motor or the battery, so your service cost goes down by around, I guess, again 4 to 5 times lower to ICE. So this is how the acceptance started. And if I talks about the last year market two wheeler. So below you can see this is the financial 21-22 data, where you Siam data. You can see that the two wheeler sold around 2 lakh 31,000 two wheelers sold in the year financial 2022, compared to only 41,000 sold in 2021 and 24,000 sold in 20. So it's almost 460% growth you have seen in 21 to 22. Because so the major reason for this growth was the acceptability of the customer and the FAME 2 additional subsidy by the state and the central government. So people have started adopting it. Now this is of the registered two wheeler. If I include the non-registered two wheeler, like a low speed and few cycles and all, which is called as a cycle but actually a two wheeler, the numbers comes around 4 lakh. So tentatively the market size is around 150,000 is the market size for two wheeler in India. So market size means number of two wheelers sold in a year is around 150,000. That is one CR 15 lakhs. Out of that, 4 lakhs been converted to EV last year, so which is around 3%. And till 2022, it was less than 1%, 0.8 or 0.7 or 0.5. But this growth started last year, and it almost 3% two wheeler converted to EV. This year, this volume is expected to around 8 to 10 lakhs, which is almost 5 to 6% of the total market. Next year, it is we are expecting around 8 to 10% market will be converted to two wheeler. So the two wheeler industry, the EV industry, whether it is lithium battery manufacturer, two wheeler manufacturer, charger manufacturer, controller manufacturer in India, they are having a growth of around 2 to 3 times year to year in last 2 years. Now talking about three wheeler market, which is almost 10% being converted to EV right now, expected to get converted around 17% this year, and 20% by next year 23-24. Four-wheeler is less now, 0.6%, although we can see that almost people are accepting it. And currently your Nexon EV or any other Tata Motors or Mahindra EV, you can have around 6 to 7 months waiting period. So this is this shows the the adaptability in the market. Bus market is comparatively higher, almost 5.5% been converted to EV right now, which is expected 8% this year and 10% next year. So this is the kind of growth you can see in the market. Now talking about, so there are two kind of, so whether it is two wheeler, three wheeler, four wheeler, mostly two wheelers and three wheelers market. So there are two kind of people manufacturer in India right now, because what was happening before EV comes into the picture in ICE, there had a monopoly of the OEMs like Tata, Mahindra, Maruti, Suzuki, and Hyundai, and all these. So maybe the five, six, maybe top five or top six in four wheeler, we're having almost 70, 80, 90% of the market share. Same in two wheeler. If you talk about TVS, Hero, Honda, uh, and Mahindra, top five will have around 80, 90% market share. But this is not the case in current scenario with the addition of EV. Currently, almost as you have seen that almost 4-5% being converted to EV, and our prediction is by next 4 to 5 years, uh, or maybe by 2027, 2028. Um, the current OEMs like your TVS, Honda, Hero, Mahindra will have only in two-wheeler market will have maybe around 40 to 50% of the market share, and rest 50-60% market share will be covered by the new age OEMs like your Ola, Ather, and your Ampere Electric, Hero Electric, Okinawa. Because right now there is no monopoly of engine, people can have their motors, battery, and based on that, there are battery manufacturers, there are motor manufacturer whom you can take these batteries and you can have your own brand, uh, and these OEMs will have their own market. Now I'll just over to you, Praveen, on your content for lithium-ion battery pack. Over to you, Praveen.
Yeah, thank you, sir. So hello guys. Uh, in next few minutes, we will focus on these points. Overview of lithium-ion battery packs. What are they? How do they work? And what are their advantages, disadvantages as compared to other types of batteries? Applications of lithium-ion battery packs, in which we will see what are the industries those are using lithium ion battery packs, such as automotive, consumer electronics, and renewable energy. Then trends in lithium ion battery technology. What are some of the latest advancement and just
Yeah.
yes. So please make it yeah. Then what are some latest advancement in the lithium-ion battery technology, such as improvements in energy density, power output, safety features, then voltage operating range. These are the developments happened in different types of lithium-ion battery chemistries. Then electrical engineering consideration for lithium-ion battery packs. For designing a particular lithium-ion battery pack, we need to consider some calculations. We need to perform some design consideration. We need to work on CFD, CFE. Those things we will look into. Then future scope for you guys, that is opportunity in the EV industry. So next, next. Okay, a battery pack is mainly consist of lithium ion cells, battery management system, and bus bar. The lithium ion cells are mainly connected in series and parallel to get a rated voltage and capacity. The lithium ion battery packs are having high energy density. They are relatively lightweight compared to their other counterparts such as lead acid and VRLA battery packs. They are having longer cycle life than the lead acid and VRLA battery packs. The lithium ion battery pack consists of multiple lithium ion cells. Those are connected in series and parallel using the bus bars. These bus bars are welded with the cells using uh, a specific welding technology. This weld technology are of different types. It might be laser, it might be spot welding. As an electrical engineer, we should be aware about these technologies because the cell to cell connection, that is series and parallel connection, needs to be properly handled, and at the time of assembling these cells in series and parallel, we need to concentrate on the cell IR also, joint IR also. That things we need to be taken care during the welding. So these are basically the components which are used in lithium ion battery packs. That is cell. You can see this is a 18650 cell, that is cylindrical cell, and then BMS, bus bar, and cell holders. These four components consist a battery pack. A battery pack is made from these four components only. But if you see the gravity of cell, BMS, then welding technology, you will come to know the process, the deepness of the battery pack. We'll move forward to the cell. Prior to cell, the basic concept of series and parallel, while designing any battery pack, we need to take into consideration. As all of you know, you are an electrical engineer, and you must be aware about the series and parallel combination of the cells or any other components. In series, if you see, the voltage is get sum up. Here on screen, you can see the 3.6 volt cell. 3 cells are there connected in series. The overall resultant become 10.8 volt, whereas the capacity of each cell remains same. Capacity is not add up in the series connection. So main point in series connection used for the purpose of getting the system voltage. So let's say my battery pack is having 48 volt. In that case, I will need 14 cells in series which are having 3.6 volt as its nominal voltage. Then in parallel, you will get same voltage but different capacity. Let's say my battery pack is having 48 volt, 40 Ah. In that case, I will need 14 cells in series and 8 cells in parallel, each cell of 5 Ah. This cell series and parallel combination you are learning from at the first year, series and parallel combination. That same basic which is required as an lithium ion battery pack engineer. The same basic concept will be useful in the industry itself. So next.
Just to add on, I think as Praveen has mentioned, I think this is the most basic part of how electrical engineering or electrical engineers are connected with battery. And in our organizations, we always look for it must be electrical engineer. Otherwise, it's so I'm personally a mechanical engineer, so I know the difference between the importance of electrical engineer in this subject basically. And so he has explained it very well. As you see, this is I think this is NMC, right, Praveen? This is NMC battery.
Yeah.
So, Praveen will also explain about the NMC, LFP, NCA, other different, sodium batteries, sodium cells, aluminum-based batteries. So the difference is basically one is, the basic difference of cells in one is the chemistry, whether it is nickel, manganese, cobalt, or lithium ferrous phosphate or NCA. So based on that, so one is this, the chemistry-based differences. One is your form factor-based differences. There are coin cells which you see in your watches, huh? Watches, huh?
Yeah, watches.
Watches, cylindrical cells, which are primarily used for two-wheeler because because of the form factor, especially cylindrical NC and NMC and LFP. So these differences also Praveen will explain, but the only difference based on this form factor, so the voltage and age capacity of each cells, and based on that, the basic technology of battery designing is how do you select your cells, the base cells, and based on that, how you make the number of series and number of parallel. Suppose I'm using LFP, so it's 3.6. LFP is around 3.2 volt, and suppose I am considering around 208 cells. So 3.2 volt, 100, 208 cells. So if I connect in series, so it will be around. So if I connect around 14 series, so it will be around 51 volt, 208 cells. Now, 51 volt, 208 cells. So we have one module. So just understand one module. So from one cell, how we have gone into one module of 51 volt, 208, and from that module, how so now a car required maybe 200 volt and 208. So I just need to add 4 such module in series. So it will become 200 volt and 208. So this is how the base is a very important. How you select the each cells and how you make the series and voltage to as per the customer requirement to pack it as per the space available in the vehicle. Over to you, Praveen.
Yeah. As explained by Shubhata sir, the cells are having different types. We'll see those in next few slides. So particularly we will see how the cell is constructed inside. The cell, basically one cell, a normal cell which we are using in our wall watches, our remote control, those cells are having nickel cadmium cells, AAA cells, battery cells, AAA. The cells, all the cell chemistry are having construction of this type. You can see the image of the cell internal view where it is consist of an anode, separator, and beside that one cathode. Here you have to pay attention on the anode. Here anode is negative, not positive. In the cell, anode is negative, which is mainly consist of aluminum or copper foil coated with graphite, carbon, or other similar conductive material. And cathode is the negative terminal. In cell, cathode is in cell, cathode is a positive terminal and anode is a negative terminal. Cathode is also consist of aluminum or copper foil, but it is insulated or it is mounted with LFP, LCO, NMC, or LMO types of uh, lithium chemistries. So your cathode determines what will be the chemistry of any cell, whether it may be nickel cadmium, whether it may be NMC, whether it may be your LFP, LMO, LCO, LTO. All these chemistries are defined by your cathode. So the cell is an electrochemical device which is used to store energy, and your cathode determines the chemistry of the cell. That needs to be note down. Your cathode always determines your chemistry, whatever the name that cell is having. Next.
Just to add on, mostly we use graphite anode, right, Praveen? Mostly we use
Yeah, graphite.
Yeah, so mostly we use graphite anode, and so now it's very interesting on cathode selection, because as Praveen rightly said, so we are battery manufacturers, so we have requirement from different customers. Somebody wants for two-wheeler, somebody wants for three-wheeler, somebody wants maybe for electric boat, somebody wants for starter motor, starter battery, somebody wants for swapping. So different customers are having different requirement. Like somebody wants for maybe the swapping, they want high life cycle, but the energy density can be less. Somebody wants high energy density, but less life is also okay, because maybe the number of cycles per day, or maybe the number of charging cycles are less for that customer. Somebody wants very high energy density, very high charging or discharging rate, because they may need high discharge current during the startup, so or maybe more continuous as well. So based on that, it's very interesting how you select the cathode material, and based on that you will get your and obviously your uh, other parts also defined on that, but cathode materials play an important role in your selection of the cells based on your customer requirement. Over to you, brother.
Yeah, thank you. This is mathematical model for the cell. You can see here, every cell is having internal resistance. Every cell is having internal resistance. The OCV of a battery pack is never be constant. It depends on the battery cells internal resistance. Here you can see one ideal power source is there. That power source is connected with the resistance in series, and internally it is connected with the capacitive reactance and resistance, parallel combination of capacitive reactance and the resistance. The whole circuitry, that is R0, then R parallel and C parallel, this constitute your capacitance, sorry, this constitute your internal resistance. And basically the internal resistance determines your battery pack stability. The battery pack stability is determined by the internal resistance. So whenever we are selecting a cell for particular application, we need to consider the internal resistance of individual cell. Then we have to calculate the internal resistance of a complete series. Then we have to calculate the internal resistance of parallel of the series. The whole calculation need a mathematical understanding. We need a mathematical simulation for this one. As all of you know, MATLAB is there. MATLAB is having a Simulink module. That Simulink module can perform this mathematical calculation for the IR estimation, the life cycle estimation of that particular cell. this can be useful. So keep in mind, every cell is having internal resistance and no cell is an ideal power source. Next. Yeah. Along with some advantages, lithium ion batteries are having disadvantages also. The main advantages with the lithium ion batteries are these batteries are with high energy density. If you see, lead acid is having 40 watt hour per kg. It means in 1 kg only 40 watt hour lead acid can store, whereas the NCA, which is the latest trend in the industry, that is having near about 250 watt hour per kg. In 1 kg, it can hold 250 watt hour, and the difference between these is near about 210 watt hour per kg. So you can understand, if I need 240 watt hour for any application, I will need only one NCA cell, whereas I will need near about 5 lead acid batteries to be connected in parallel to get that much of watt hour. So the weight with lead acid will be higher, the efficiency with lead acid will be lower, whereas in NCA the weight will be lower, due to which your efficiency will be higher. Basically, lithium ion battery packs are useful where the energy density required is more. The application, such as let's say your Avenger bike, your Harley Davidson, these bikes are required for long drives. So in that case, if I am using lead acid battery, it will not provide me the range which I require. I have to go for 300 to 500 kilometers in a single charge. In that case, lead acid will not be useful. For that purpose, I will require a lithium ion chemistry with lower weight, lightweight lithium ion battery, that which will allow me to travel 300 to 500 kilometers in a single charge. Then next advantages of lithium ion battery pack is it is having low self discharge rate. As we earlier say, the every cell is having internal resistance. The internal resistance causes self discharge. Lithium ion battery packs are having lower internal resistance, due to which the cell consumption of those battery packs are lower as compared to lead acid and nickel cadmium. Then no memory effect. Lithium ion battery pack do not suffer from the memory effect, which is a phenomena where batteries lose their capacity over time due to self discharge. Then lithium ion battery packs are useful in the application where you required high C rates. You can say the charger, iPhone charger or OnePlus mobile phone charger, that can charge your battery pack up to 80% within 15 minutes. Those mobile phones are having lithium ion battery packs. You can imagine, if other than lithium ion battery packs, you use lead acid in that mobile phones, what will happen? The size, first of all, uh, will not be compact. In that case, the time taken to charge will be much more. So lithium ion battery packs allow you to charge them fastly as compared to their counterpart. Then a normal lithium ion battery pack goes around 1000 to 3000 cycles of charge and discharge. Whereas if you see the lead acid battery in your home appliances, that will go only for 1 hour. After 1 hour, you have to, for 1 year. After 1 year, you have to replace those battery pack with the new one, or otherwise you will not get the capacity required for driving the load of your house for 8 to 10 hours. The lithium ion battery packs allows you to operate them in a longer lifespan. They provide you the capacity in best way, as they are having a lower internal resistance. Along with these advantages, lithium-ion battery packs are having some disadvantages also. These disadvantages impacts on their safety. The first disadvantages of lithium-ion battery packs is cost. Lithium in the market is a costly metal, and the main component in lithium ion battery pack is lithium only, which causes these battery packs are expensive, which may they make them less accessible to some consumers. The temperature sensitivity of lithium ion battery pack is much more. These battery packs are much sensitive to the temperatures, due to which there are chances of thermal runaway incidents in the operation, during the operation. Then lithium ion battery have been known to catch fire, explode. If you see in the last year, a number of the accidents happened due to these battery packs. Some of the people had has lost their lives in these incidents. For that reason, the safety matters with these lithium-ion battery packs. Over the period of operation, the capacity of these battery packs degrades, which means they may not hold the capacity required for the operation of any system. Then recycling of these battery packs is too much costly. It is difficult, as these battery packs are containing nickel. This nickel is not degradable, and it is harmful to our life. Lithium is also harmful to human life.
Yeah.
These-
So
these are-
just to add on, I'll differ with Praveen and in some of the point. So it's a, I also attend various conferences. So people every time ask whether lithium-ion batteries are safe or not. So yes, actually being a technical expert, Praveen's job is to make you understand what is the risk related to it. Like he has explained everything in detail. So to be very frank, I think the fire incident. So normally I also answer in various conferences like this. I know this will be a probable question as well, maybe after during the QA session as well. So whether lithium batteries are safe or not. So let me tell you, fire incidents has happened in lithium battery pack as well as non-lithium battery packs, that is EV or ICE vehicles. So all your top brands, including your BMW, Volvo, or any other world-based brand, having had their fire incident reported. So normally, yes, lithium batteries are like your fuel or like your petrol or diesel. So if you add fire in it, definitely there will be an accident or fire. To be very frank, on a layman language, I need to make you understand. Yeah, it's very important that you need to understand the safety concern, like the way you can't lit a cigarette in a petrol pump. So similar way, because petrol or diesel needs an trigger point to start the fire. Similar way, lithium ion batteries are we are handling almost 40 to 50 lakhs, that is around 4 to 5 million cells per month. And let me tell you, we are storing around 5 to 6 million cells at a time. So these are very safe, to be very frank. The only thing is you have to handle it carefully, right, Praveen?
Yeah, correct, sir.
So we have to handle
Yeah.
it very carefully. It's not like that. So normally fire incident happen because of some external or some internal issues. Praveen will also explain how during the battery pack designing we take care of the internal triggering point and external. We call it tempering or maybe external factors which cause the fire. So and we'll also explain how we make 100% safe battery, especially with this new AIS Amendment 3, Amendment 2 Phase 3, Amendment 3 Phase 2 by ARAI and Government of India, which makes our lithium battery packs safer than European standard. To be very frank, even some European companies, we have some European partners from Germany and Austria, so they are sometimes confused why you need these much safe pack, because the kind of thermal propagation requirement Indian government has given is far ahead of any European requirements. So over the time, Praveen will also explain how we make or how we handle the battery carefully, like you have to handle your petrol or diesel and make it a safer pack. Over to you, Praveen.
Yeah. As we gone through the disadvantages, to compensate these disadvantages, there is one device which is monitoring and controlling all these defects inside the battery pack, which is known as battery management system. A battery management system is an electronic system that manages a lithium ion battery pack or any rechargeable battery, such as protecting the battery from operating outside its safe operating area, monitoring its state, calculating secondary data, reporting that data, then controlling its environment and authenticating and balancing it. These are the main functions one BMS can perform inside a battery pack. Whatever it may be, if any thermal runaway situation is there, BMS will inform. If there is overcharging is happening, BMS will inform. If there is imbalance happens in between the series combination of the cells, then this can be informed and protect the battery. The BMS mainly consists of a typical microcontrollers, analog to digital converters, and a communication interface. It may include features like voltage balancing, temperature monitoring, and overcharge or discharge protection. The emerging trends in the battery management field is constantly evolving with new technologies like AI and machine learning. Uh, the main focus of the industry right now is on artificial intelligence and machine learning. So, as an electrical engineer, for the future, you can start concentrating on these topics: artificial intelligence and machine learning, to improve the BMS performance and reduce the cost of the BMS. Additionally, there is growing interest in second life applications of batteries, where used batteries are repurposed for less demanding application after they have reached the useful life cycle. The BMS is performing different operations. Let's say the application related to the auxiliary, that is pre-charge, contact control, and cooling control. Pre-charge, the pre-charge basically it is a point of the starting of any connection. You are drawing power or you are turning on key of the vehicle. In that case, what will happen? Battery pack opens its MOSFET or contactor. In that case, inrush current from the battery pack start flowing through the bus bar, through the bus to the load. Here load will be your controller side, which is having some capacitance, which is having some inductance, and your motor that can be damaged due to that surge current. So pre-charge circuit is a must in any BMS. This pre-charge circuit is nothing but to compensate the surge current. We are keeping one resistance in series with the output of battery pack. It is nothing different, just the calculation required to calculate the value of that resistance as per the controller. Then cooling control, number of battery packs are having different types of cooling technologies, that is passive cooling, active cooling. Whenever there is a need of active cooling, the BMS is providing the control to the cooling system to protect the battery pack from overheating. Then different types of protection available inside any BMS. Those are short circuit protection, overload protection, overcharge protection, deep discharge protection, and overheating. Here, the main you can see, you can assume some customers, if by mistake shortens the positive and negative of a battery pack, and it is a lithium ion battery pack and there is no BMS, what will happen in that case? It will blast. It will definitely blast. So the BMS restrict the battery pack from getting short circuit. It will turn off its contactor. It will turn off its MOSFET whenever it detects any short at the output terminal. Then overload and overcharge. If my battery pack is of 48 volt, I am charging them up to 58 volt. But what if my charger didn't cut and it goes beyond 58 volt? In that case, also it will blast. So to manage these protections, BMS is having some algorithms. BMS are having some logic inside their controllers, which are preventing the user from abusing those battery packs beyond this one.
So add on to that, I think so. Me and Praveen always face an issue to get the right person for BMS. So correct, Praveen, and we so just to add on, like for electrical engineering, it's very important that BMS. Because I'll try to add some keywords. Maybe Praveen can add few more. Like BMS is a kind of hardware which requires software to with us kind of inputs. It's like temperature inputs, pressure sensing inputs, current sensing inputs. Based on that, it takes the decision. So I think that is where India needs collaborations between institutes like especially engineering institutes and between the and industries where I feel there's a huge gap between what we learn during the our BTech or BE and what we actually apply in case of the industry. So some of the keywords I can tell you, like embedded system design, then your C plus and programming in C, MATLAB. Some of the experience of MATLAB, how we can simulate the life of the battery, how we can simulate the working of the BMS. Maybe Praveen, if you can add few more.
Yeah.
The
Python is also there. Python
Yes.
Used to estimate the state of charge, state of health, and life cycle estimation of the battery pack. These are the latest trends which are normally being used in the BMS development. The BMS is heart and brain both of the battery pack.
Yes.
Heart and brain is called for the BMS. BMS Then it is also used for the information storage, information display, or for any communication from battery pack to vehicle controller, vehicle dashboard, or to the swapping station, or to IoT. It is having the facility of the communication like CAN, RS485, I2C, then UART. All these communications are there inside the BMS, which allows you to communicate the data over the air. That can be possible with this BMS. So the main function to compensate the disadvantages of lithium ion cell is performed by the battery management system. That's why we require battery management systems inside any lithium ion battery packs. So this is a huge topic. BMS is a separate topic, which we can you can
It's an endless topic. Yes.
yes. The basic terms used in BMS like DOD, SOC, and SOH. What is DOD? The DOD is the operating range of a cell. Let's say my cell is having voltage range from 2.8 volt to 4.2 volt. If I am using the complete 2.8 volt to 4.2 volt range, that will be my 100% DOD. But if I am not utilizing that much, I am charging my battery pack from 3 volt to 4 volt only. In that case, my 2.8 to 3 volt and 4 volt to 4.2 volt, this band is unusable. In that case, my let it may be my DOD will be 80% or 85% in that scenario. So depth of discharge of any battery decide your life cycle and safety. Because if you are not charging your battery pack 100%, you are not utilizing it 100%, that will be beneficial for your longer life and safety. If I am charging my battery pack, my battery cell up to 4.2 every day and discharging it up to 2.8 every day, it will uh, uh, it will decrease my lifespan. But if you are setting up your DVD from 3 volt to let's say 4 volt, in that case it will prolong my battery's life cycle. So your mobile phones are recommend to not discharge below 20%. Is it all the mobile phones are showing indication of 20%? Why it is so? It is for reminding you that but if you are consuming battery below 20%, there will be chances of battery failure, like or the battery will not prolong the life for you. Then state of charge. State of charge of a battery pack is the current state of the charge. It is estimated by different algorithms like Coulomb counting, current integration, Kalman filter. Different estimation methods are there. These algorithms you can these are already available over the MATLAB. You can check the MATLAB Simulink. There you can see SOC algorithm already are there in builds. You can modify those. Currently in the industry, set accuracy is highest one of SOC algorithm. You are having the scope to increase that accuracy from 92% to 95%, 95 to 96, 97 up to 100%. SOC estimation is totally based on the battery pack state how it is measuring the current, how it is estimating its store charge. All these can be defined through a algorithm. Then SOH is also there. SOH basically depends on the life cycle. After some of the years, let's say after 1 years, your battery pack, which was earlier having 40 Ah capacity, but after 365 cycles, 365 days, that capacity dropped by 20%, from 40 to let's say 35. In that case, the SOH also decreases. SOH is the state of health estimation based on the remaining capacity of the battery pack. Then applications, as sir already told, regarding the applications can be the lithium-ion battery packs can be used in different applications like portable electronics, smartphones, tablets, wristwatches, smartwatches, laptops, then electric vehicles. This field is the booming field, in which you are as an electrical engineer having a lot of scope in this one. Then these are the types of lithium ion, as sir already explained that there are different types of chemistries of lithium ion. The main which are trending right now are LFP battery packs. Those are lithium iron phosphate. The nominal voltage of these battery packs is 3.2 volt. It can be charged up to 3.65 and discharged up to 2.5 volt. These are the safe battery packs, safe battery cells, but with lower energy density. Then nickel, manganese, cobalt, called abbreviate as NMC. The nominal voltage for these cells are 3.6 volt. It can be charged up to 4.2 volt and can be discharged up to 2.8 volt. These are having more watt hour per kg than the LFP, but it is not stable than the LFP. LFP is much more stable than the NMC. And as compared to the life cycle, NMC is not giving that much of life cycle, but LFP is giving more number of cycles for any particular application. Then nickel cobalt aluminum oxide, that is NCA. This is the latest trend which is having the highest energy density, but this is these cells are having some disadvantages in the those are having less lifespan, near about 500 cycles, and these are not safe. These are same as NMC, but due to its capability to hold the high energy per kg, these are useful in the application where number of cycles doesn't matter, but the range matters. Wherever there is a need of let's say 500 kilometers, 600 kilometers, these cells are useful, but these are not useful wherever there is a need for the prolonged life. Let's say I need to use my vehicle for 5 years. In that case, these cells will not be useful. Then
So add on to that, I think as Praveen has explained. So normally these three are if I consider this chart also. So NMC, LFP, and NCA. These are the three major chemistries which currently is in market. So primarily NMC used for two-wheeler and LFP used for three-wheeler as well as high voltage battery pack for cars, commercial vehicles, or any other application. Why? Because NMC are thermal runaway can happen in NMC, whereas in LFP the chances are thermal runaway are not that much high. So LFP is a much safer chemistry compared to NMC because NMC have a chance of thermal runaway. So now the problem with two-wheeler that you have lesser space, so you have to accommodate more energy in lesser space. So and also the life cycles in NMCs are low. But two-wheeler runnings are not that high. Like normally it's city run, people runs about per day around 40, 50, 60 kilometers, maybe 80 kilometers, not more than that. So if you are having 100 kilometers range, so maybe current year, so it's almost 0.5 times charging a day, almost 150 a day. So 50 a day. So even with 3 years, you will be 750. Not more than so 3 years on 750, and in 5 years it runs around 750 to 1000. So NMC is quite comfortable for NMC, but for NMC you need to have a lot of safety precautions. So that's what NMCs are used in two-wheeler, and it's cylindrical. NMCs are mostly used in cylindrical form, and even the C rates, like your charge discharge C rates, are low compared to LFP. But you need very high speed like 70, 80, 60, 90. It's quite okay. I'm talking about the medium speed two-wheeler. So NMC is quite convenient for two-wheeler because the space is less, need less cycle life, and C rates are low, 0.5, 0.7 C. So suppose you are having a 40 Ah capacity battery pack, current consumption with maximum speed maybe 20 to 30 Ah, 0.5, 0.7 C. 1C is the maximum capacity use, 0.5. So suppose 40 Ah capacity battery pack, you are continuously, if you are taking 1C, that is 40 Ah, so it will the battery will be discharged to zero within 1 hour. If you are consuming 0.5 C, it will be zero in 2 hours. So this is how it works. LFP is much safer chemistry. Energy density is low, but you need more space. Three-wheeler you have more space. Cars you have more space. Commercial vehicle you have more space. So that's why we go for LFP batteries. Like BYD use LFP batteries, and the C rates are also high. You can go up to 1C, even 1.5C, 2C also in some of the LFP chemistry. So that's why for this application it is used. This is how it is. Over to you, Praveen.
Yeah, so next. Yeah, these are the validation tests as per the different standards performed in our in-house facility. Well strength check, then short circuit test, then thermal propagation, thermal performance test, handle strength, vibration test. All these tests needs to be carried out at the time of validation, so that the battery pack which we are manufacturing goes with the full confidence in the field, so that there will not be any harm to the user. The different standards are there which defines these test criteria. Basically in India, automotive industry standard for two-wheeler, that is 156 is there. These 156 recently amendment, we got the amendment in this one, amendment 3 last year by the Ministry of the Vehicles. In this amendment 3, they have the body which was expert body which was there. They have suggested some test. They have modified some test criteria. These test criteria we have to validate at our facilities. But battery capacity test is there, then ACIR test is there, cell life cycle test is there to determine the to estimate the life cycle of a cell. Right now, we have to keep the battery pack up to its full life on until it gets zero capacity. We have to test that cell, but using the different technology, let's say Python, let's say artificial intelligence or machine learning model, MATLAB. You guys are having the scope in this area where you can estimate the life of a particular battery cell, uh, that is accelerated aging. You can estimate this without waiting for 2 years, 3 years for getting the test result. Then welding strength test is there, which is a quality test, and which is performed over the modules. Then IP67 and 68 tests are there. These are as per the standard IEC 60529. This is the international standard, which is same is followed in AIS 156. And here IP first digit stands for the uh, for the material which is that is, let's say it is waterproof and dust proof. If you see the format, if you see the standard, the 67 and 68 for water and dust proof. Then handle strength test. Here, this is also quality test. As per the requirement, we need to perform this test. Vibrations test as per AIS 156. You guys can go through the AIS 156 standard. It's amendment 3, and the phase 2 requirements. Regarding that one, you can check over the internet. You just Google those documents, you can read, you will get more clarity about this test, how this test in the industry can be performed. This can, you can check that one, just go through that one. Thermal shock and cycling test, mechanical drop test, mechanical shock test, external short circuit test. Then Other than this, there are ore charge test, or deep discharge wake up test. These tests are there, which include in the AS 156. If you go through this document, no one will stop you from entering the EV industry. These are the Gita Bible Quran of automobile industry, AS 156. So next, then for safety related, every cell is having CID. At our end, the cell which we are using is having current interruption devices inside those. If there is formation of the gas during the operation, these CIDs gets open, and that particular cell out of the, let's say, 300 500 cells get disconnected from the series, get disconnected from the connection, and save the battery pack, save the battery pack. Then module level safety. For module level safety, we are having busbar level fuses, which allows, which saves the battery pack from flowing higher current in case of short circuit at the output side. Then pack level safety, we are using external fuse, which saves the user's life by opening as per the ROC conditions. Then we are also having the, as discussed, VMS protections like overcharge protection, short circuit protection, under voltage protection, or temperature protection. All these are there, which basically saves the battery from any abuse.
Just to add on to this, I guess I just want to make you understand what happened. Like if you talk about the automotive industry, so as Praveen has also discussed about the test. So I normally give this experience. So example. So suppose you are using a process or a product which will be used for your home appliance, a kind of television. Second product is your automotive, which will be running on the wheels. Third is your maybe aircraft. Fourth is your satellite. So what happened in automotive industry, which is not taught during your college life, which you learn with your experience, that a stationary application, a non-automotive application, normally the quality checks are less than automotive. But in automotive, normally we that's why people talks about DPMO, Six Sigma, all these terms where the defects has to be, you have to create a process where the defects has to be zero. Zero means zero. That's what they talks about. Six Sigma process, 3 to 3.4 defects, I think, per million. So that's kind of numbers talks about. So if you're talking about the aircraft, it should be further low. If you talk about satellite, it should be further lower than aircraft. So number of checking procedures increases in automotive compared to non-automotive. Automotive to aircraft, it further increases. Maybe one quality checks, you have 3 to 4 area where it should be ensured. Maybe one defect, you ensure that defect should be checked in 3 to 4 process. Aircraft, you ensure during 10 process it gets checked. That one parameter. Maybe for satellite, you need to check 100 times a process. So this is how you create a process. So similarly, so for if you compare a ICE or versus a EV, so normally basically if you look at their process also, you just remove the engine. Suppose I'm talking about a car. So basically you change the drivetrain, except drivetrain, and almost rest of the parts and processes are same. Suppose it starts with the welding process, so your body welding is same. No changes in body welding. Your paint shop is same. No changes in paint shop. Your even the wiring harness, dashboard, everything is same. The only thing in place of even your axles are same. Only you are not putting the engine. In case of engine, your drive shaft, the drive shaft. If it is a two-wheel drive, so your drive shaft get the drive from your motor shaft, not from the propeller shaft, or maybe the engine main shaft. So who drives this motor? The battery runs this motor. So you have to place, and so it's a very layman language I'm trying to explain you so that you can understand it better. So you are just removing the motor, engine, gearbox, and the propeller engine and gearbox, and you are replacing that with a motor and the battery. And you define your the mileage you want to move, the range you want to move, the maximum speed. Based on that, you design maximum torque. Based on that, you design your maximum voltage and maximum current, total kilowatt, the capacity of the battery. That's how you design the battery, and that from that battery your life cycle and everything. And it's not very easy, but based on that, so it's a kind of layman language how you design the battery, because it is the ultimate source of your vehicle. So in battery, you need to ensure. So as we were also talking about the fire incidences, so we call it external or internal abuse. There can be two kind of protection. One is from internal abuse and one is from external abuse. So what kind of external abuse it can be? There can be a short circuit in maybe the wiring harness of the. So battery itself cannot trigger a fire. It has to be triggered by internally from a cell. So we have a cell level protection. Suppose there is a cell which comes under thermal runaway. So you have your fuse system which remove the the pressure and the smoke comes out of your pressure sensing bulb. and with the thermal propagation requirement as per this new amendment, it will not go to the next cells. So it makes your pack perfectly 100% safe. Then from any external abuse, maybe short circuit because of your charger, because of any parts of the vehicle, if any short circuit happens, so there are external fuses which cut down your battery. There are the BMS have some MOSFET level protection which saves your battery from over current, over temperature, or over voltage. And we also, during the making of the battery and the vehicle, we check these protections at BMS level, battery level, as well as vehicle level before sending it to the customers, which makes your product 100% safe. Over to you, Praveen.
Yeah. Uh, Basically, these are the basic formulas needs to be considered during designing of any battery pack. Uh, these are you are going through the first year formulas. You will say how basic it is. Actually, the battery pack design, its calculation, and its implementation is much more easier. But you need to understand. You need to understand the application of your learnings. Whatever you are learning in your 4 years degree, these are the basic fundas which needs to be carried forward after the passing parade also. After passing your degree, you have to carry forward these fundas with you. That is Ohm's law. I have seen a lot of candidates. I have interviewed lots of, but they are not carrying these basic information with them. If they are having this basic information like Ohm's law, then power calculation, power is equal to V into I, Ohm's law is equal to V equals to IR. No one can stop you from entering the industry. Just remember these formula for calculations, uh, and you will get the entry into the industry. The next, the scope for you in this industry is in the R&D department, where the electric vehicle industry is heavily dependent on the research and development of new technologies and innovative solution. For the purpose, and electrical engineering students required, and you can be one of them to get through into the R&D department. Then electric powertrain. The powertrain is the heart of electric vehicle, and it is essential for electric engineer student to understand the design and operation of electric powertrains. This includes the development of electric motors, power electronics, and battery management system. Autonomous driving. Autonomous driving is a rapidly evolving area in the electric vehicle industry. As an electric engineering student, you can contribute to the development of autonomous driving system by studying areas such as sensor technology, machine learning, artificial intelligence, and control system. Charging infrastructure. The availability of the charging infrastructure is critical for adaptation of the electric vehicles. As electrical engineering students, you can contribute to the development of charging infrastructure by studying the design and implementation of charging station, as well as the optimization of existing charging processes. Overall, the electric vehicle industry presents many opportunities for electrical engineering students to contribute to the development of new technologies and solutions. By focusing on these areas such as powertrain design, battery pack design, PMS design, autonomous driving, charging infrastructure, and sustainability, electrical engineering students can make a significant contribution to the growth and success of the electrical vehicle industry. This is all from my side. Sir, over to you.
Yeah, so I think we have also tried to, during our presentation, we have also tried to use some keywords which may be helpful for the students as well for their future endeavor. And so these are we have already discussed about the NMC, LFP, and NCA chemistry. Apart from that, these are some future chemistry for your knowledge. Tesla 4680, solid state batteries, lithium sulfur batteries, new generation lithium ion batteries, pouch cell, sodium cell. So these are future batteries which will take around 5 to 10 years maybe to have a mass implementation or mass usage. Apart from that, also I'll try to the EV electric vehicle, two-wheeler, three-wheeler, or four-wheeler gives you. So this is the new product safety requirements as per the new standards. Um, so in batteries also, we produce batteries, not only batteries, but we also produce charging stations, swapping stations, battery management system, IoT. So basically, and as well as mobile apps for monitoring your vehicle, monitoring your battery, monitoring your swapping stations. So all these end-to-end application we provide, and for that also these are the major customers which we are supplying: Ampere Electric, Bigos, Revolt, Kinetic, Hero Electric, Quantum. So these are our major customers we are supplying to. On a closing note, I think EV is more about creating the ecosystem. So it's you need manufacturer, supplier, dealer, service center, energy management, battery leasing, charging stations, mobile apps, car renting, leasing, government agencies, smart building infrastructure, electric car to direct consumer, and saving in fuel and higher revenues with Mission Go Green. So I think the entire ecosystems in India is developing a lot. As I mentioned, maybe around 3% two-wheeler. In next 5 years, I think almost 15 to 20% of two-wheeler will convert to EV. Three-wheeler, almost 20% next 5 years will convert to EV. Even the four-wheelers, almost 10% plus, 10 to 20% will convert to EV. And buses also almost 20% will convert to EV. This is the projection for next 5 years. And these are different application what we have discussed. So this is the mobility towards future. Currently, it is asset based. Maybe your car which you are using right now, maybe you are using a day not more than 2 hours, maximum 2 hours. So maybe out of 24 hours, only 2 hours you are using your car. So maybe it's less than 5%, or maybe 5 to 8% asset utilization. Whereas the new trends are coming towards EV and AV, where autonomous vehicle and electric vehicles, where it will be more or share mobility, where people will be using share mobility like your Ola, Uber, because your running costs are pretty low, 5 times lower than your ICE. Although your capital cost is almost same currently, or almost 30-40% higher than this thing, but your overall life cycle cost is lower than your ICE. If you compare that. So the future is towards smart mobility, and we can see working with the industry, 25 to 30, 2025 to 2030 will be the highest growth level we will observe in EV industry as well as in AV industry, because of the government policy and the movement currently. Thanks to you. Over to you, Abhijit, for the Q&A session.
Thank you, sir. It was a really informative session. We have a few questions that we got during the session. We like to have the question answer session. So there are few questions. Shall I give you the question, sir?
Yeah, sure, please.
Shiva Varman says that in the long run, does it make financial sense to purchase an electric car instead of a gas-powered vehicle?
Yeah, I think we have already answered this, because your with the FAME subsidy, if you talk about two-wheeler, the cost is same, IC versus EV, whereas four-wheeler it is almost 20 to 30% higher, but with the subsidy it is almost within 10-15%. But your running costs are, if I talk about a car, two-wheeler you get around 3 to 5 years of warranty for the battery as well as the entire vehicle. which you don't get for ICE. Vehicle you are getting, I know about the Tata and Mahindra vehicles, which you get around 8 years of warranty, which is and the cost is same. When running cost is 1/5. So it's quite viable. That's why people are. That's what I was saying during the presentation. Before 21, it was not viable. Customer were not adaptable, but the adaptability is much higher currently compared to in last 2-3 years.
Okay, sir. So second question that came is Mr. Somnath Banerjee says, "What is the future of electric vehicle in India in next 5 years?" I guess that was answered during the
Yes.
session. Third one was also during the session. How will the batteries be used in the vehicles? I guess it was also explained. Lastly, there was a question from Mr. Abhishek Poddar. He says that is it really true that the recent founding of lithium ore in Kashmir could boost the lithium manufacturing industry in India? And how long do we have to depend on Chinese technology for the manufacturing?
I think from the beginning we started the presentation that we it started very non-standard way, getting SKD CKD from kit from China, and then in last 5-7 years it is. I think today, Praveen, today only Hero has launched this vehicle, right?
Yeah.
Today only Hero has launched this vehicle with battery with 100% localized parts, and the only thing is, if I talks about the localization, almost 100% parts are now localized. Only thing we get it from China, the cells, which India already 5 like Geo. Amar Raja, 4-5 more companies have started cell manufacturing, which will be commercialized by 2025. Then we'll get the cells in India. But for iron ore, now cell will be localized. After that, your supply chain of the cell manufacturing. So supply chain, I think 2025 onwards. The requirement of the lithium ore will come, where in the meantime also the government India need to test the kind of quality of the lithium, and also whether it can be used for that application or not, which is not yet confirmed, which will take around, my understanding, 3 to 5 years. So I don't think before 2030 or maybe 2028, 5 years from now at least, to use that iron ore. Any comments from Praveen, your side?
Yeah, the lithium ion metal which we have found in the Kashmir is will be beneficial for reducing the cost, as already some Indian cell manufacturers are developing the technology for the production of lithium ion cells. So the export duty which we are paying to export the cells from Chinese supplier or Japanese supplier, or any different supplier, German suppliers, these will tremendously drop, and the EV will be accessible to all categories, all financial categories, families. That will be beneficial in that case.
Yeah, and I think if you look at China, so definitely we get it from China many parts, but China is, to be very frank, 10 years, I think 10 to 20 years ahead of us on technology front. So I think we should look at the story of China, how they have created that EV infrastructure, or EV revolution, and that can reduce our learning time and learning curve. And I think currently we are dependent in China, but in 2030 onwards, I think dependence, although in last 7 years the dependence has gone down by almost 40 to 50%. Currently only cell we are getting, but and also this iron ore and usage and localization will come beyond 2030.
Sir, few more questions are coming. Mr. Niranjan Kumar says that, sir, is there any developments in regenerative charging during the usage of vehicles?
Praveen.
Yeah, yes. In regenerative charging, actually, there is a simple phenomena which is called as the rated capacity of your MOSFET or contactors. Let's say during the regeneration, my battery pack is capable to handle 3C charge rate, but the controller side is providing you 5C pulse. In that case, there should be there is a mechanism inside the BMS which reduces this pulse to 3C and allow that 3C to charge the battery pack. This regeneration might, if that facility is not available inside the BMS, it can damage your battery pack cells, and that can be not useful for the battery pack prolonged life. But if there is a controllable circuitry that the MOSFETs rating, contactor rating inside the BMS is having uh, the rated as that actually it is called the integration. It is called integration. You have to select a MOSFET based on the regeneration capability of the controller, because whenever you are braking, that motor is generating a reverse current that is going through your controller converting that, it is stepping down that regeneration pulse and providing it to the battery pack. If that is not controllable, in that case your auxiliary battery pack cells might get damaged, and there this facility is now already available as per the AIS phase 2 amendment 3 phase 2. It is already available inside the BMS.
And I think if you, just for your information, so any vehicle if you want to run in Indian on Indian road, so you need to have a ARAI certification or a ICAT certification. I think as per AIS 156 standard, and as per that also, regenerative braking is a mandatory requirements from AIS 156 point of view. So it has to be a regenerative braking system. Otherwise, you can't run this vehicle on Indian roads. Correct, Praveen?
Yeah, correct.
Okay, one more question, sir. Sonam Darge Bhutia, he says that, sir, it is advisable to learn edge computing for EV or HEV domain.
Sorry, can you repeat it?
EV or HEV domain. Hybrid electric vehicle or just
No,
electric vehicle domain.
the entire question.
Shall I repeat?
Yeah. Please repeat the question.
He says that, sir, it is advisable to learn edge computing for EV or HEV domain.
See, HEV is already there. Praveen, I think if you can answer and then I'll add.
Yeah. Actually, in India, we are just observing either IC engines or either AV. But outside India, there are the vehicles which are having hybrid technologies, either based on the IC engine and lithium battery packs, or either on the gas or mm, I, IC engines, that is petrol. These are already there. Whatever you are going to study basically focusing on the electric, because there might be there some future scenarios might be like that, other than the electric, some of technologies will be there which might operate on the air, like aluminum air technology is under development. that can be used. Hydrogen fuel cell, that technology is under development. But the base of all this technology will be electric only
Yeah,
electric.
so you have to use the motor. You can use
Yeah,
different power sources, but so I also agree with you. Like if you look at the Indian government initiative and the movement, so it is more towards EV, not PHEV or what do you call hybrid. So basically, hybrid is I'll say it's just a eyewash. हाइब्रिड से ऐसा कुछ होता नहीं है इफ you have to go for full electric, otherwise hybrid is no is most of the hybrid cars in India right now, they're only used they have used the battery only for the starting application and not for the running application, even not in low speed. The age will be for the future will be for definitely EV, no doubt. And as uh, Ravin also mentioned, apart from, so the motor will be definitely there. How to drive the motor? There are 2 3 options. So definitely one is battery, one is your fuel cell. So fuel cells, aluminum fuel cells are leading currently. Although it's not commercialized, I'll say, because not in marketing that way. Although your Toyota and Hyundai have launched their car, but it's not in mass currently. But the age will, the future will be for EV, that is motor plus battery. For battery, they can use different chemistries or different form factors, or motor plus fuel cells of methane or aluminum. Yeah, that's what.
Sir, though we are running out of time, but seems there are a lot of questions, sir. So few more questions, if you can answer it quickly, sir.
Right.
Mr. Jayantobhushan Basu says, what is the scope of other type of energy storage devices in India, especially for EV applications?
Other
yeah.
Other
areas.
type of energy storage devices in India.
So I think one is the ESS, energy storage system for solar inverters, the stationary applications. ESS market is huge in India. I think maybe bigger than automotive market, especially this solar power storage and other hydro and other power storage. So that's a huge market. Apart from that, we get a lot of inquiries of different type of customers, like the forklift, even the electric boat, tractors, and from apart from automotive, drone applications. Uh, Apart from this, your so anywhere, I think mostly will be the stationary storage will be the bigger one. Rest is there, drone and everything is there, but the bigger one will be stationary storage for solar and other.
Okay. Jack Wallis, he says that what are the main challenges to split water at low input potential to produce hydrogen for future hydrogen requirement as energy storage systems?
Oh, okay. So problem is not generating the hydrogen, but the problem is transporting the hydrogen. That is the biggest challenge right now. So the cost of transportation of hydrogen is too high. So that is the challenge right now, and even the safety is a concern. Otherwise, hydrogen fuel cell is a better option. And generation is not a big thing. The costing is lower than producing any other source. But the transportation solution is still people are looking at it. Anything, Praveen, your side or?
Same, sir. Safety matters with the hydrogen. Hydrogen cannot be stored under any scenario. So that storage facility which is required, that is having a safety risk. So that's why that separating hydrogen ion from water is not a difficult task. It is a easy technology, already available technology, but storing that hydrogen is a risky factor. So that will impact on the hydrogen fuel cell.
Sir, one more question we have in the chat box. Sonam Darge Bhutia says, how does bidirectional charging work and how soon are we gonna see it booming in India?
What kind of charger?
Bidirectional charge.
Five directional charge.
Bidirectional.
Praveen, any
Didn't
idea?
get what? Didn't get what? Bidirectional charging. It means
Bidirectional
to
charge.
say battery. It means to say battery to battery charge.
Okay, so I
Bidirectional
think
charging is
I
already
think
there.
yes. So what I can understand. So if I got it right, so there are technologies which in some of the European countries they have started it like uh, from from your grid you can like from your home charging you can charge the vehicle and your vehicle can be used as your power source for your home as well in case of power failure. So if it is that, I don't think it will be easy in India. It will take some time. Even some of the countries, the power, the power charges are different. They have different slabs of power charges based on the utilization. As you cannot store the power, so it has to be transmitted. So in those countries, that kind of business model started taking into a shape. But in India, I think it will take some time. Not now. I can't see the visibility as of now.
Sir, there will be last question from my end also. What I ask you that, sir, now there are very few electric vehicles as we can see compared to IC, but in the coming days we can expect that there will be a lot of electric vehicles. So whenever they will be coming, like the fuel station right now, when they will be coming to the charging station, there will be so much power intake from there. So how do we cope with this, or how India is ready for this?
Yeah, so currently, I think this is a very common question in any forum, and the Indian government has already, started towards this. And one of the solution will be, solar based, and many of the business case has, started emerging as a, selling solar power in charging stations. So I think that will be one of the solution, as well as the government of India is working towards that. I don't have the exact data right now, but yes, the government of India is also working on towards that. Towards apart from the renewable energy also sources also. That is one of the mission for government of India to convert almost 70% to renewable energy. And apart from that, for non-renewable also, a lot of initiatives have been taken, and it will not be a challenge that I can confirm you, but I don't have the exact data, the numbers and all currently with me.
Thank you, sir, for this lovely and informative session. I guess we have answered all the questions that were available in the chat box. Now I will pass on to Mrs. Rabuni Pal, who will be giving the vote of thanks for this session. Thank you.
Thank you, Subhajit. And thank you. It was a wonderful session. Mr. Praveen Vakere and Mr. Shubhabrato Ghosh. Yes, you have give a detailed knowledge about the electric mobility, battery storage system, EV industry, lithium ion cell, sodium cell, and what is the difference between with respect to chemistry, with respect to form factor, basic technology of battery cell, construction of cell. Not only that, how the cell is used in day-to-day life, our and that means whole BMS, that is battery management system. We have gathered a lot of knowledge, and also artificial intelligence and machine learning with respect to EV and AV. You give a new era to our students, how they will be useful for our day-to-day life. Not only the students, for us also. Yes, thank you, sir. It was a very, very good, knowledgeable session. And before end of this session, I want to say thank to our managing director Satyam Rai Chaudhary, who give us the platform to give to success this event. Our whole TIG group, and our honorable principal sir, Dr. Mithun Chakraborty, our administrator sir, Jaideep Guo, our head of the department, Dr. Arup Das, our electrical engineering departmental all faculty and staff members, last but not the least, our beloved student. Thank you, sir. Yes, hope so. We'll meet again, and if it was face-to-face meeting, it will be much more interesting. Thank you, sir.
Thank you. Thanks for the wonderful
Thank
session.
you.
Thank you,
Thanks,
sir.
Nick.
For the participants, we would like to say that the feedback form has been already given to you, feedback link, and the feedback link will be active till 5:30 p.m. So kindly submit your feedback form. Thank you, sir.
Thank
We
you,
are
sir.
closing this session.
Okay, thank you. Bye.
Thank you.
Sir, closing. Thank you, sir.